Let's quickly look at the different categories of ARM processors that are available to us. We've already seen the different kinds of families and architectures, but now let us look at the classifications of ARM processors. So, first category of ARM processor that we have is the ARM classic processors. So, ARM classic processors include your ARM 7, ARM 9, ARM 11 families, as well as ARM 7 TMDI, which is still the highest shipping 32-bit processor. So ARM 7 based processors are still used in many small and simple 32-bit devices. So you can see many boards or many computing systems or many uh, devices that are manufactured which have ARM based microprocessors. You can see their families, and you'll find ARM 7 is used in a lot of 32-bit devices. So these are your classic processors used for general purpose processing, like in case of a Raspberry Pi based system where you have OS and you can implement any kind of application you want. Even you can do Unix based programming as well as Python based scripting on Raspberry Pi system, right? And many such devices are now available in the market which use ARM based processors. Even many mobiles, like if you see the Snapdragon or Qualcomm, a company that manufactures these Snapdragon processors, you will see that they also use ARM-based microprocessors. Next category is the ARM embedded processors. Now, embedded processors obviously they are going to be different from classic processors because we know the definition of embedded by now. These are supposed to focus on particular applications. They are not exactly general purpose, and they are energy efficient and power efficient also. So these are energy efficient, simple to implement, and are mainly developed for advanced embedded applications. So it is not meant for general purpose applications but advanced embedded applications. So ARM Cortex M processors. This is a series that is used in making embedded processors. They are further divided into several processor cores like Cortex M0, Cortex M0 Plus, Cortex M3, Cortex M4, Cortex M7. So these are some of the processors that are used in embedded processors, right? So this M series is used for embedded applications. Then under this embedded processor category, there is actually one more series, that is the ARM Cortex R series. Okay, this is also an embedded processor only. It's used for embedded applications, but there is a slightly different objective here. What is that? These processors or cores are used for providing solution for real-time embedded systems. Real-time embedded systems, we have discussed this earlier also, where time is of the essence, where all the applications or whatever processing has to be done, it is extremely constrained based on time. So for those kind of applications, the Cortex R series is used. These provide high reliability, high fault tolerance, and real-time responses, which is very important in case of real-time embedded systems. Because when we are implementing real-time embedded systems, there is no fault tolerance at all. You cannot expect any fault to occur, and the response of the system towards any kind of input, any kind of situation should be instantaneous. It cannot wait, it cannot hang, it cannot delay to provide the response. So Cortex R series processors are used in systems where high performance is required and timing deadlines are extremely crucial. So again, time constraint यहाँ पर बहुत important है. So in those cases, Cortex R series is used. Otherwise, for general embedded systems, Cortex M series can be used. Then the next category of the processors that we have is ARM application processors. So अभी तक हमने क्लासिक सीरीज देखी है, एम्बेडेड सीरीज देखी है. नाउ दिस इज द एप्लीकेशन सीरीज which is designated by Cortex A. So this series of processors are the highest performance processors from ARM. So this is entirely based on performance. ठीक है, यहाँ पर कोई compactness, energy efficiency की बात नहीं हो रही है और focused on specific applications. They are meant to give highest performance as possible. So they are used in powerful mobile devices, compelling technology products like network devices, consumer appliances, automation systems, automobiles, as well as different embedded systems, जहाँ पर performance is of the utmost priority. The Cortex-A processors are again divided into high performance, high efficiency and ultra high efficiency type processors. So all these taglines, they are related to the same thing, that is performance, whether it is a high performance or whether it is a high efficiency or ultra high efficiency. And each subdivision has several types of processors cores that are available, and they have different features which can be chosen. The appropriate core can be chosen according to the application that we are developing. So now in the syllabus we have basics of processors and ARM only. No one is asking you to do any kind of programming. But in my opinion, if you do want to start with understanding ARM architecture and starting the programming for ARM based series microcontrollers or processors, then you can go for Cortex M processors. Cortex M processors हमने अभी कहाँ पढ़े थे? In the embedded processors. Cortex M processors, they are not very costly also. They are available, and many prominent microcontroller companies, they manufacture boards using these Cortex M processors. Like I don't know if you have heard of this series, that is STM microcontroller. It's a company. STM is a company that manufactures variety of microcontrollers. So there is a series STM32F series that is entirely based on your Cortex M ARM processors. Same way में Texas Instruments का TIVA series है, that goes like TM4C 123G series. So this is also based on ARM Cortex M processor. तो यहाँ पे जो प्रोग्रामिंग स्टाइल एंड आर्किटेक्चर उस थोड़ा डिफरेंट रहता है एज कम्पेयर टू योर नॉर्मल 8 बिट 16 बिट और 32 बिट माइक्रो कंट्रोलर जो कन्वेंशनल होते हैं, जो हमने पहले यूनिट्स में पढ़े. So if you want to work, you can Google or you can go to Amazon or electronic product sites and you can search for some of these boards that come with Cortex M4 based processor. So you can start programming.